One of the definitions of continuity for a function is if I can draw the function without picking my pen up, it's considered to be continuous. Well, this particular function, f of x equals x cubed minus 1, is a typical cubic that's just been bumped down 1 unit. And it is in fact continuous everywhere. Now the fact that the limit as x approaches 2 equals 7, we're going to find out if it's continuous at 2 or not with this proof here. They're picking out an epsilon of 1/8, and we're going to show that for that given epsilon we can find a delta such that as long as x is within delta of 2, that f of x is going to be within 1/8 of 7. So what we like to draw here is something called a little epsilon delta box. So here's 2, and you'll see at 2 it's way up here at 7. And they just said, well, let's make epsilon equal to 1/8. So what we do is, there's 7 and there's 2. We're going to go up 1/8 and down 1/8, and we go straight across on the graph, and then we want to go down to this point and this point, and we're going to have two different distances. We'll call that one delta 1 and this one delta 2. So here's how we find those. Well, if epsilon is 1/8, that means this is 7 1/8 and this is 6 7/8 on the y-axis, and all we have to do to find delta 1 and delta 2 is to solve backwards for x and then take the difference between that x value and 2 that they want our limit to. So the first one, let's take a look at delta 1. Delta 1 is going to equal the absolute value of 2 minus this x value for when we solve for this. 6 7/8 is equal to x cubed minus 1. So to solve for x, we're going to add 1 to both sides. That's going to be 7 7/8 equals x cubed, and then just take a cube root of both sides, and we end up with x equaling this 1.98953 if we round to 5 decimal places there. And then if we want to find delta 2, we're going to take the absolute value of 2 minus x for x when we solve it for 7 1/8 equals x cubed minus 1. Again, add 1 to both sides, so we get 8 1/8 equals x cubed. Go ahead and take the cube root. I just realized I forgot to put the cubes over here. So take the cube root of both sides, and this time I get x equals 2.01036. So if I plug this in up here and I plug this one in up here, I get the delta 1 is equal to it looks like 0.010471, and the other one, delta 2, is equal to 0.01036. And then the delta that I'm going to choose that fits inside this little epsilon box is the minimum between those two. That's the delta I want to pick. So the delta that I'm going to choose is going to be this guy. It looks like the smaller one, 0.01036. And here's what I know now. As long as if x is less than 0.01036 away from 2, then we know f of x will be within 1/8 of 7. So that's how we can show, that's how we pick the delta for the given epsilon. They told me that they wanted to find delta such that if we're within delta, we're within 1/8 of 7. We went 1/8 above and an eighth below and 1/8 above. We solved for each one of those x values. each one of those x values, when I put them in here and here, give me the two deltas. Always pick the minimum delta, and now I know if x is less than this far away from 2, then f of x will have to be within 1/8 of 7. So that's how we choose our delta. Good luck, Sean.